Hi, I have two things to present today. The first thing is Skylar, who is an AI that I want to use in my videos. Skylar, maybe you can explain by yourself. I forgot. It's first time use, so I need to boot her up first. So let's boot Skylar and let's hear what she has to say.
Hello. My name is Skylar. My job is to help Soren find information on the web and do corrections when he make mistakes. And he do that a lot, but please don't tell him I said that.
Thank you, Skylar. You, matter of fact, hurt my feelings a bit here. Start having secrets with my subscribers and viewers. Well, okay.
You are welcome.
Well, I did create her, so I should know her temper and behavior. No. What I want to do today is to make a gasket for this cyclone here. I made a wooden flange in my CNC machine to make it a little bit stronger for the basket and the lid. But I still worry a bit to get in false air between the cyclone and the lid. So I want to make a gasket in TPU on my Sidewinder X1. And before that, I will make a construction of the gasket in DesignSpark Mechanicals. And maybe, Skylar, so I avoid to make mistakes that you have correct very often, you could explain the viewers what TPU is and maybe shortly what DesignSpark Mechanical is. In the meantime, I will load DesignSpark into my computer. Let's go to it.
Of course. Your question is my command. Searching the web. Found the requested information. A cyclone is a device that by creating a tornado, it will separate the dirt from the air. This is a powerful way to clean a workshop, as example. And now to DesignSpark. DesignSpark Mechanical is a 3D CAD solution designed to help engineers and educational institutions use inbuilt 3D models to create and export technical drawings in various file formats, as well as STL files, for use in slicers. It offers measurement tools, which enable designers to analyze the size and shape of designs created.
In DesignSpark, which by the way is free, I will put the link in the description, we work with sketches. And here I want a top-down view on the Z-axis, so I go down here and I just click, and this will now represent our print bed. So, sketches, and this one is quite easy because it's based on circles, and the outer diameter of our gasket will be 110 millimeters. There we are. It just make me set a home view, so if I get out here, it will be easier to come back to normal. Then I have the inner circle, which was 71 millimeters. There. And then I need a kind of reference circle, and for that I just use the normal one. And because I have the holes here, and I know that from this edge to this edge there's 5 millimeters, so I just go to 95.5, I think should be correct. 5 here, and I should now make a 7 millimeter circle. Let's try to measure if this is correct. It's 3.75. We need to have 5 here, so 1.25, that's 2.5 more. Yeah, 2.5 more, and that is 2 from that is 3, so I will have 93 here. So, and now it should be correct. It would be 93 because I didn't take here. We have exactly 5 millimeters, as you see, to the edge. So next, next hole will be here, right? Next hole will be there. Science Park is suggesting it will be 7, as you see. And well, that is matter of fact our gasket, but we need to extrude it, and I need to remove my reference circle. That is here. It's gone, and this is now our circle. So now we need to extrude it, and that's quite easy. We use the pull tool, and I will take a little bit here, and here we will go. And maybe we should make it, I guess maybe 3.5 millimeters. And the rest here we will take away. And right now we have made a gasket, which looks very nice, and we want to export this as an STL file. Let me take it over here, gasket version 1. So we have now made an STL file, and I want to import this to a slicer. So let me just open up that. By the way, Skylar, it is your first day here, so I will give you the honor and choose the slicer we want to use.
Thanks, Soren. Today I want to use the Prusa slicer. I have never tried to use the Prusa slicer with TPU. Searching for gasket STL file. Found it, adding gasket to Prusa slicer. Loading Prusa slicer, version 2.3.1. Just follow my instructions. Click on Print Settings. Chose 0.2 mm Flex Artillery. Check vertical shells and horizontal shells, have 3 perimeters and 3 solid layers. Click on Infill. Set fill density to 40%. And fill pattern to grid. Click on Speed. Enter 25 mm speed in perimeters. First layer should be 33%. Click on Filament Settings. Wait. Analyzing Kung Fu Flex for best nozzle and bed temperature. Temperature calculated. Nozzle 228.435 degrees. Bed 61.632 degrees. You can enter nozzle 229 degrees. Bed 62 degrees, that will do it just fine. Click on Cooling. In Fan Settings, enter 1 layer. Click on Printer Settings. Check nozzle diameter is 0.4 mm. Set retraction length to 2 mm. And retraction speed to 20 mm per second. That should do it. Click Plater. I have estimated a total printing time to 2 hours and 41 minutes and 32 seconds. Click the Slice button and see if I am right.
Wow, you were damn close. It says 2 hours and 41 minutes. Well done, Skylar. I'm impressed.
You are welcome.
So, Kung Fu Flex is a very flexible material. It can stretch, you see here, 4 times the length. And that's a reason why you cannot have it into the filament sensor. So, what you do to not get an error on the filament sensor, or when you are printing, you just let a piece of PLA being left in the filament sensor, and then you load directly to the extruder, that is here, the flexible filament in there. Now it is time to remove the old filament if you still have something in there. So let me power up the artillery and let me enter the temperature to, let me see, 230 degrees is okay. So, and while this is heating up, you will have to loosen the pressure on the filament behind here by pushing this wheel up. And I do that because we do not want too much pressure on the flexible filament, because that will cause that it quails like that inside the extruder into the gears. So that's why I push it up quite a lot. And remember, when you load PLA or PETG or whatever, next time you need to tighten it again. Now let's see where we are, 100 and 211. The positive thing with artery is it heating with 220 volts. Yeah. But here we go, it's out. And now we want to load the flexible filament, and that has to be done very, very, very carefully, because as it says, it is flexible. And you see here, we are loading, and hopefully we are not loading correct. I see that now. So we give it another shot. Let's see if we can hopefully. Yeah, it's not easy. Well, let's try again. I think we got. Yeah, you see here now the flexible filament coming out at the nozzle. So we are happy. Yeah, so it's time to stop the print. So I go back, and it's time to go to the home and and load the gasket STL file. Let me see. Gasket, and we confirm, and the print is starting.
Just a comment. The start code is making a G28 that home all axes, and then lift the nozzle, so it is easier to clean the nozzle for filament while it is heating the bed and nozzle.
So the bed is 62 and the nozzle is 229. We will now prime the nozzle, and I see there's coming filament. I always follow the first layer, and so far it looks good. So let's see what's going on out here. It lays nice on the bed. It really, really does. This looks amazing. And the first layer is the 33%, and that is from the 25 millimeters we want to print with when we have made the first layer. And also the fan will start first here at the first layer. That was the one we entered to fan start on first layer. As you can see here, it's still off. So here we have, still looks good. it looks good. So I take a chance and let's see in an hour how far we have been coming with the print.
I will add some background music. Searching the web. Found Endless Motion from Benjamin T. So. Playing soundtrack.
So I got my gasket, I did present Skylar, and yeah, it's only to say now bye bye and see you next time. Thank you for watching.
I'm very happy to be a part of this team. Thank you to all our viewers. Bye bye, see you next time. And happy printing.